Great. I want to start by introducing Chen. She's going to be our first speaker, and this is going to be a pretty exciting session. We have a lot of really good talks. So we're going to track air pollution under the smoke and dust with satellite data. That's really challenging.
Hello, everyone. This is Soja from University of Iowa. Welcome to HAQAST meeting. As the first talk of today, I will talk about our work to support the PM2.5 exceptional events demonstration in smoke and dust plumes using the Earth Optical Central Height AOC observations from satellite. So first, I'd like to thank our team members from the University of Iowa for their contribution to this work, and I also would like to thank our collaborator, Dr. Univ, the PI of the Temple team, to support our Temple LSH product development, as well as our stakeholders from environmental agencies across the US. A lot of study has shown that the PM2.5 pollution in continental US CONUS is significantly influenced by smoke and dust plumes. For example, by analyzing the long-term data of the black carbon and PM2.5 concentration derived from machine learning method, we has found that the increasing wildfire emissions reverse the black carbon and PM2.5 trend from decreasing to increasing in Western US since 2010. From ground measurement, Miller et al. Have found June 2022 transatlantic Saharan dust outbreak elevated the 2022 mean annual PM2.5 for Gulf Coast region, and also pushed at least 2 ground size to exceed the natural ambient air quality standard. So the Earth observation provides significant data source to track the smoke and dust plumes. For example, from the models of various aerosol optical depth data, AOD data, you can easily track the long-range transport of smoke or dust plumes from the source region to downwind region far away. However, this two-dimensional information of total column aerosol burden is not enough to derive the surface PM2.5 concentration, since the smoke and dust plume can rise to high altitude during transport. So that means the aerosol vertical distribution measurements is necessary. The active remote sensing measurements from the LiDAR provide really robust, accurate aerosol extinction profile, which is really useful to derive the surface PM2.5, but its direct application is limited due to the low spatial coverage. So our group has spent the last few years developing a new satellite aerosol optical central height AOSH product from the PISA environment from satellite. So even though it's hard to get the detailed aerosol profile from the PISA environment, similar as that from LiDAR, but the PISA environment in oxygen absorption band also provides some information about the aerosol layer height. So we assume the aerosol vertical profile follow a Gaussian distribution defined by 2 parameters, the peak height and half width. So the peak height represents the altitude where the aerosol extinction is the strongest and cause the AOSH here. We have shown the effectiveness to use this observed AOSH to correct the MERA2 overestimation of PM2.5 in the downwind region of the smoke plumes. So our group has developed several LSH products from different satellite sensors, including EPIC, onboard Discover, and also Tropomi. We are now working on the Temple operational LSH product development to provide the hourly measurement of the whole CONUS which is really useful, and it also has a high spatial resolution. So next I will show some smoke and dust plume cases, demonstration using the tropomi and tempo LSH and LD data. So the animation here shows the hourly tempo observations about the LD, LSH, and UV aerosol index from geostationary satellite. And the bottom red two panels that are tropomi, LD, and LSH product. Since it is on a polar orbiting satellite, so it can provide a global measurement once per day. So we can clearly see this fast smoke transport during this single day from the tempo observations, but the spatial pattern from the tempo and tropomi data are still similar. So next, I will show some detailed analysis about the dependence of the surface PM2.5 on this smoke LSH. So the bottom right panel shows the daily tropomi observation of this LSH. And we can clearly see that in the fire source region, the LSH observation are really low and PM2.5 is really high. And in the downwind region, this LSH can be higher than 6 kilometers, and PM2.5 is much lower. Although the tropomi can provide this difference between the far source region and downwind region, the tempo can provide more information about the diurnal variation of smoke plume and surface PM2.5. For example, let's focus on the eastern Iowa region highlighted by this blue circle. And we can see that in the morning, this region is still not influenced by this smoke plume, and the PM2.5 is still low. And when it's close to the, when it's close to the noontime, the smoke transports to this region, but the LSH is still high, so the PM2.5 increased a little bit. And in the afternoon, the smoke plume in this region descending. So the LSH become lower and lower, and the PM2.5 increase a lot. So that shows the significant correlation of the surface PM2.5 with this LSH observations. So here is another dust plume case, also last year in New Mexico and Texas. So from the thermal observation, we can clearly see the fast dust storm formation from morning and spread and transport fast in the afternoon. And we can also clearly see the change of the LSH and the dramatic increase of the PM2.5. So finally, I'd like to introduce our website. Actually, this near real-time tropomi LSH products have been visualized on this fire AQ system, and also coupled with the aerial observations at the tropomi over past time. And so we can clearly see some exceptional events demonstration for the smoke and dust plume transport from our website easily. So, I also would like to mention that we will also host some regular meetings for the stakeholders and open to public to analyze some exceptional smoke events during the fire seasons. And so if you are interested, feel free to subscribe to our email list, and we will send you any notice about the Zoom link and the start of this meeting. And here is the link of our website and also the QR code. Yep, I think that's all. Thanks.
Thank you. We're going to save questions till the end and we'll have a panel discussion. Our next speaker is Leif Paulson. He's from the Wyoming DEQ, so he's one of our stakeholders. So we had first she, a scientist that's providing the information and data, and now we will hear from Leif.
Thank you. Thank you. And good morning, Leif Paulson, Wyoming DEQ, our Quality Ambient Air Monitoring Supervisor. Lauren Diversey, our Exceptional Events Technical Writer, is also here with us. And just want to talk a little bit about a case study from a year and a half ago, the elk fire near Sheridan, Wyoming. So just showing a little bit about Sheridan, its monitoring history, the elk fire's influence, and our much more limited use of satellite data than others here at this conference, and a few takeaways. So I always like to start with a little bit about Wyoming DEQ. We are in Cheyenne in the southeast part of the state, though we have field offices throughout. In the Air Quality Agency, there's about 80 of us overall. We have primacy for ambient air monitoring, permitting of minor major sources, stationary compliance, resource management like emissions inventories, meteorological forecasting, rulemaking, state implementation plan development. Lots of facilities in Wyoming, overall minor sources, but over 100 active Title V sources. And you can just see on the slides some of the types of facilities we regulate and permit. For air monitoring, we have 25 active stations in Wyoming, despite being number 50 in population, but we are quite active and present throughout the state. We have at some locations a low-cost sensor networks, and we have 7 objectives for our air monitoring network met by all the monitoring stations. So Sheridan, Wyoming is in the north central part of the state. It's about 20,000 people. It's kind of becoming a nice place to live, work, and play. It's nestled near the Bighorn Mountain Range. This area used to be a non-attainment for PM10, and this is one of the Air Quality Division's success stories. We were redesignated as attainment unclassifiable years ago. And because of the history of non-attainment, we've been quite active in monitoring there. We have a SLAM station there, we have a mobile gaseous station, and a field office with some monitoring equipment as well. And just you can see the police station, our mobile station, and the field office. So these mobile stations, what they are, they're self-contained trailers that we park at a location. We need ready, accessible electrical power for them, year-round, full-time access for QA/QC activities, and we do our best at these mobile stations to meet the EPA siting criteria. We have 3 active ones right now. 2 more are being developed and built, and they will be ready by the end of this year. So overall, start of 2027, 5 mobile monitoring stations that monitor for just about everything, as you can see, meteorology, particulate matter, the full gaseous suite. So for Sheridan, we went there in April 2024 to April 2025 due to a finding in our network assessment to visit the community for more gaseous monitoring. And why do we pick where they go to? It's just we want to look at cities and towns with no history of deep monitoring, and our compliance team may have locations for us as well to investigate. So moving to the elk fire, this was 2024 when it started, or excuse me, late September 2024, and went through mid-November 24. Almost 100,000 acres in size, lightning-induced on the Bighorn National Forest. For context purposes, 2024 was Wyoming's 2nd worst year on record for area burned. For those of a certain age, 1988 was the worst year with the Yellowstone National Park fires. And you can see just the perimeter of the elk fire where Sheridan is at as well. And so usually we like, making the news is a good thing, we always think, but here in this case, NASA Worldview, we made their weekly image here, as you can see, showing daily progression of the elk fire in October of 2024. And now turning our attention to the ambient air monitoring data. So on the left is the police station slams there with many exceedances of the 24-hour PM25 NACs in early October. On the right, the Sheridan Mobile Station, similarly many exceedances of the PM25 NACs. Same monitor equipment at both stations. We, in the field office, have a low-cost sensor active, a purple air sensor. And what I did here was use the EPA correction factor equation as referenced on the bottom of the slide, and then compared that to the National Ambient Air Quality Standard as well. And during that time, we saw what would be exceedances as well if it were a federal equivalent or federal reference method monitor. And on the right, I generated just a short correlation chart to show that everything, the police station, the mobile station, the field office sensor, were generally in agreement with strong, high correlation. Looking at satellite imagery now for the Terra Modis, we see the elk fire in the north central part of the state. Also, just to drive home the point of 2024 being a bad year for fires in Wyoming, Pack Trail in western Wyoming was also around 90,000 acres. There's a little bit of color on the figure as well, showing the aerosol optical depth, just to drive home that it was a bad, lots of smoke in that time. This is, again, early October 2024. Looking at our use of tempo, so we looked at level 3 NO2 tropospheric tempo data, and I just want to plug the EPA's Remote Sensing Information Gateway, a great graphical user interface tool for state and local agencies that maybe don't have full experience of looking at this thoroughly. So you can see our times of interest on the right and our settings as well. And you can observe a little bit, just to point out, Sheridan would be kind of the central part of the map. North of that's Montana, but some color there as we advance in time with NO2 readings there. And what this translated to, so the mobile station does have gaseous equipment, as I mentioned, ozone and nitrogen dioxide. So checking ozone on the left, we topped out maybe 50 parts per billion for the daily 8-hour average, thankfully short of the 70 parts per billion standard. And on the right, nitrogen dioxide, we maybe maxed out about 28 to 30 parts per billion, and the standard's 100. So we were fine there in terms of gaseous, just what it observed versus what we saw from from the tempo level 3 data. So to summarize a bit, this smoke from the elk fire did influence the city of Sheridan. You can see those images on the right there of a clear day and a not clear day. And we did see several PM2.5 exceedances from the police station and the mobile station. I just want to encourage, any state or local agencies in attendance on the call about the many, many, many accessible resources that there are to help with examining data from fires, preparing exceptional event demonstrations. There are vast resources available. Gathering your information early is critical. We did comply with 2024 PM25 NACs to get the demonstration for calendar year 24 to EPA a year ago. Our next steps at our Cheyenne Encore station, we have several low-cost sensors sited along with federal equivalent and reference method monitors. So our next steps will be to perform analyses on these various low-cost sensors to understand more. We're kind of excited as well. I believe late fall this year is some addition of the aerosol products to Tempo's toolbox that we're excited to see and use. And with that, I just want to say thank you for your time and for the privilege of being here.
Thank you. You gave us lots to think about. Our next speaker is Amanda Fritz, and she is another stakeholder from Connecticut. So we are excited to, do you want this? Okay, all right, sorry. We're playing a speaker game here. We're excited to hear from her, and then we're gonna wrap it up with a scientist in the end. So we've got half and half, 50%.
Hello everyone, my name is Amanda Fritz and I'm an air quality meteorologist and forecaster at the state of Connecticut. And today I will be highlighting some satellite data products that we use to track and analyze smoke plumes. So starting off here is a map of our air monitoring sites across the state. We have 12 sites that measure a variety of pollutants and meteorological parameters, and 8 of those sites measure PM 2.5, and those are highlighted with the red circles. Now, in order to highlight some new products that I've been looking at, we will be going back in time to 2023. So this table shows the 24-hour average PM 2.5 values on significant smoke days in 2023. So to be included on this table, at least one site across the state needed to reach USG levels, and that's the level where air pollution begins to negatively impact the vulnerable populations, so those with asthma, young children, and older adults. And I will be highlighting some of the Tempo aerosol products. So the best day due to data availability and just what the data is showing to highlight is October 1st, even though it is the least significant event that we had in 2023 and recent years. So starting off, here are the Air Now daily PM 2.5 maps for both September 30th and October 1st. I'm showing September 30th just to show the buildup of the event. So on both of these days, we saw widespread moderate PM 2.5 values across New England. And on September 30th, we saw more of those USG values for the northern areas. And on October 1st, we saw those for more of the coastal areas, especially in southern New England. I also have the tables showing the monitoring sites in Connecticut with the daily average PM 2.5 values. So basically on September 30th, we saw a range of values from low to high moderate, almost reaching that USG threshold. And then on October 1st, we saw more of the low to mid moderates with the exception of our Groton site, which reached USG. So looking at the hourly PM 2.5 values, we see those increasing at all of our monitoring sites in the early morning hours, decreasing around daybreak, and then continuing to increase to USG levels later in the day. And all of those sites began decreasing back to moderate values at varying times in the afternoon, evening, and overnight hours. And they mostly remained moderate throughout the October 1st. The exception here is Groton, which saw increasing PM 2.5 values throughout the day, eventually reaching a maximum value of 57.1 micrograms per meters cubed before midnight. So I am showing here the 15Z surface analysis maps to kind of give you a better idea of how that smoke plume was transported into Connecticut. So I have September 29th on the left through October 2nd on the right. There's 3 things I really want to highlight here. The first is that general area of high pressure in the eastern United States, with that stationary front moving southward over Florida on each of these days. And the second is looking more at New England and particularly Maine. We see a high pressure area over this area on September 29th and 30th. And then we also have a low pressure system off the North Carolina coast on September 29th. That's moving northward on September 30th and then begins to slowly move offshore on October 1st and 2nd. So now how does this relate to smoke plume location? Here is the HMS smoke plume, so basically the intensity of those smoke plumes on each of these days. So I have September 29th in image A through October 2nd in image D. And I have the chronosphere on the left and then zoomed in version on the right so we can better see what's going on in New England. So basically, we're seeing this light smoke plume over the eastern United States where we saw that general area of high pressure, and that lower boundary of that smoke plume is that stationary front that was moving southward over Florida each day. We also see on September 29th and 30th, when that low pressure system is moving northward, we see the medium to heavy smoke plume over New England, particularly Maine. And then as that low pressure system is moving offshore, we see that smoke plume being transported to coastal areas. In image C, on October 1st, we see that for the Mid-Atlantic and New England areas, and then further south on October 2nd. And then here's just another view that we use, the Goes East geocolor imagery, to see this smoke transport. And we basically see the smoke plume in the same locations that the HMS smoke plume showed. It's just a different way to view it. The main point here, though, is that the smoke plumes can be obscured by the clouds, so particularly on September 29th and 30th. So on September 30th, we did see those moderate PM 2.5 levels that were pretty high, but we can't see that smoke plume because of the clouds. And then taking a closer look at what happened on October 1st, we see that significant smoke plume along the coast from Virginia to Maine, and the image on the left at 9 a.m. By 1 p.m., the middle image, we see that smoke plume is moving offshore, and then by 4 p.m., that smoke plume is very, very slowly moving offshore, so it's still impacting southern New England. Now on to the part that I'm really excited to show, some of the new products that I've been looking at. So first of all, I would like to give a shout out to Shobha Contributa from Noah Nesdis and Amy Huff and Hai Zhang from STC for access to the data and answering all the questions I had. So first of all, we have tempo aerosol optical depth. So basically that's the measure of how much sunlight is prevented from reaching the ground by those aerosols. And the main values we're looking at here is 0.5 to 1, showing the hazy conditions, and the values greater than 1, representing the significantly reduced visibility. The second product is the tempo aerosol layer height, which shows how high in the atmosphere those aerosols are located. And then the third is surface PM 2.5, which is basically calculated ground level PM 2.5 based on that satellite data. And this, NOAA and NASA are in the process of transitioning these products to operational, and we are really, really excited about that at CTD. So here's the first look at these products. So this is 10 a.m. The image on the left is the tempo aerosol optical depth, and we see those high values of 0.5 and greater for coastal regions, particularly eastern Connecticut. And then looking at the aerosol layer height in the middle, we see that those pollutants were pretty close to the ground, mostly about 0 to 2 kilometers, but about 3 kilometers in some locations. And then the important thing to note here is that ALH is only retrieved for pixels with AOD greater than 0.2. So those white areas inland are not necessarily cloud cover, that's just the lower AOD levels. And then the image on the right is the surface PM 2.5. And this is a really great example, and this is kind of one of the images that I really wanted to show and why I wanted to focus on October 1st, because we can see that USG plume starting to approach our Groton monitor, and we can't necessarily see that just looking at our monitoring data. We could use purple air data, but if we're just looking at monitoring data, we don't necessarily see that plume approaching. And then looking at 1 p.m., a few hours later, we see those higher AOD levels are slowly moving offshore. They're getting closer to the ground as that plume is moving offshore. So the aerosol layer heights are about 0 to 1 kilometers. And then we do see that now the USG plume has reached Groton, and that is intensifying to show unhealthy levels as well, although the monitors are not picking up on that. Also, an important note is these are all the version 1 products, and there have been improvements made since then, so I'm looking forward to seeing that when those are available. And then looking at a few hours later, 4 p.m., those very high AOD levels are now offshore, but still impacting southern New England. We still have those pollutants close to the ground, and we still have the USG levels for Rhode Island and our Groton monitor. And we also can see the good levels creeping in from New York and New Jersey at this hour. So some key takeaways is historically significant smoke events have not been a concern for Connecticut. We did have the 2016 Fort McMurray fires, but we didn't really have anything significant before that. But there have been increased occurrences in recent years like 2021, 2023, and 2025. These products, as well as some other products I didn't have time to show, allow us to better track those smoke plumes and create more accurate and timely air quality forecasts and warnings for the public. And these new tempo aerosol products not only help us understand previous smoke events, but they also will aid in tracking smoke plumes near and far in the future. And then here's just my contact information. Thank you.
Great job, everyone. We have one more speaker, Travis Toth, and so have your questions ready. He's going to be talking about LiDAR, the vertical in the atmosphere.
All right, good morning. Yeah, so I will be talking about improving smoke or PM 2.5, including smoke and dust analysis using LiDAR observations. I just want to thank my contributions, or the contributions from my team members, collaborators, and end users. So I'll just start a little bit of motivation for this. So when we think about estimating PM 2.5 from space, there's been a ton of studies that have used the passive sensors like the geostationary, as well as MODIS and MISR and those sorts of satellite sensors. But the challenge in that is that they're passive sensors, so that they're column integrated. So it's not necessarily getting what's happening at the surface. So what I'd like to think of as a complementary approach is to use LiDAR, which is going to give us those profiles. And so it gives us the vertical perspective, including near the surface. And on the right there, I'm showing what we call a Calypso curtain plots. I'll talk a little bit more about that in the next slide, but essentially it gives you a view as the lasers moving through space, where the aerosols and clouds are in the atmosphere. And on the top, you can see an example of an aerosol plume around 5 kilometers, but it's fairly clean near the surface. So you can imagine a passive sensor taking observation of that. That might kind of affect that relationship. On the other hand, on the bottom, we see some near-surface aerosols by those enhanced backscatters, but it's clear up above, so kind of showing the advantage and the strength of using these vertical profiles. I won't go into a lot of this here, but for those that might be unfamiliar with LiDAR, so the passive approach we know is like that camera view, but the LiDAR actually sends out that light. It's an active sensor, so it sends out the laser beam, interacts with the particles, and then we measure what that the backscatter light is at the LiDAR. And this allows for that profiling at high vertical resolution. On the bottom is just a little bit of an explanation of some of the stuff I'll be talking about with Calypso, which was our spaceborne LiDAR mission that ended in 2023 after 17 years. And that's just showing another example of where we can see the aerosols and clouds and getting that vertical component. A little bit about my technique. It's using those aerosol data that we have from Calypso and applying that to back out the PM2.5 estimates near the surface. So on the left there, I have really just what is a fundamentally definition of mass concentration, which is the division of the extinction coefficient, which is what we can retrieve from our LiDAR data, and dividing that by the mass extinction efficiency, which we have from field studies and lab work and the literature and those sorts of things. So by just taking the simple division of that, we get an estimate of the mass concentration. On the upper right is a little more detailed of the algorithm, and I've added some parameters there that take into account the aerosol size distribution and aerosol hygroscopic growth as well. So if we use the extinction coefficient and we plug that into that equation that I showed on the top right, we can get values of PM2.5 near the surface. So this is some of the previous work that we've done applying this technique over CONUS for a large subset of the Calypso record. And in the middle is daytime Calypso, on the right is nighttime. On the top is looking at it from a mean perspective, and then we have trends on the bottom. And the whole point here was just to show how the spatial variability, if you look across CONUS, we could see how it compares fairly nicely with the co-located EPA when that's gridded up over the CONUS. So it's capturing that spatial variability from a mean perspective. From trends, the same type of thing is showing up where we see in the eastern CONUS where we have those negative trends, and then some portions of the western CONUS where we see the increasing trends, and then that's even showing up in the in situ data. So it's kind of showing from like more of a long-term perspective. Really briefly, I want to talk about my current HAQAST project, which is really fundamentally to keep improving these retrievals and applying them to more current observations using our current LiDARs that we have now in space. But this first objective was kind of to back up a little bit before PM2.5 and look up the optical parameters. So aerosol extinction, and a lot of this came out of discussions with Jim Zeichman at EPA. That's his plot there on the right, and he did some internal work just for a few case studies looking at CMAC aerosol extinction, which is on the top, and Calypso on the bottom, just showing how we do see this difference with Calypso being larger than CMAC. So one of the things we wanted to do was do this long-term evaluation of CMAC, which has, using Calypso, which has not been done before. All the validation has been done in very specific type of cases. So don't have time to go through everything that we're finding here, but what we did is we co-located the Calypso and WRF CMAC surface aerosol extinction using the CMAQ data from the EPA Equates project, which we have from 2006 to 2019. So that's the grid that you're seeing there is the WRF CMAQ grid and co-located with Calypso. One of the things you might notice right away is how Calypso is, in fact, larger than CMAQ, actually quite larger, which is in line with what we found, what Jim Seichman had found for those case studies. Even though some of the spatial variability it does look similar, two regions to me really stand out in the eastern Canada, where we see those really enhanced aerosol extinction, which isn't really showing up in the WRF CMAQ data. We're looking into that, what could be causing that. And then off the coast of California, we see those really large values as well, which is interesting that it is showing up in the CMAQ data, but just not anywhere near the magnitude as is with Calypso. And then another way of viewing this is just through scatter platform. I won't spend a lot of time on this, but if you look at this is Calypso on the X and CMAQ on the Y. This is just showing when we put everything together, not all that great of a correlation or relationship. I have a bunch of statistics on there that probably are difficult to read, but we have biases as low as high as 0.06 per kilometer. When we break that up between water and land, though, we do start seeing a difference where we see a better relationship over water than over land. And I didn't show all the other plots we have for these Calypso aerosol types, but we wanted to look at when we break this up into aerosol classification from Calypso, and not surprisingly, for marine, we see a better relationship because that's only going to be over water, but for dust and smoke, doesn't look as great. And interestingly, we found the best for our clean continental type, which is really what we consider as an aerosol, our background aerosol essentially. So we don't have a lot of it, but we do see the best relationship and a mean difference of around 0.007. So a little bit, so as far as the current work, just we're looking more into seasonality, breaking this down by region, and then looking at trends, and especially case studies, because that's where we want to go with, especially when we're looking at wildfires, for example. And we're going to bring in the airborne high spectral resolution LiDAR data, since we have those under flights with Calypso. So that's what I'm showing on the bottom left there, where we're currently looking at those, and we'll continue with that work. So overall, when we're looking at LiDARs for air quality applications, we have this long-term Calypso record, which gives us a really long-term record that we could look to try to increase our understanding with air quality research and applications. For current observations we have from EarthCare's ATLID, which is ESA's ATLID, which is a spaceborne HSRL. We could use those for more recent case studies. And then Calypso and ATLID will be used together for our upcoming HAQAST Tiger Team activities. So we'll have wildfires, our dust plume work, and then we really want to look into exceptional dust demonstrations of LiDAR profiles that would be useful for air quality managers, so specific case studies. And ultimately, we could use both Calypso and ATLID to try to understand and develop these applications such that when we have these future spaceborne LiDARs from NASA, for example, NASA's Falcon missions, which were just recently announced, that we'd be able to hit the ground running all that much more quickly and have develop these applications. So that's all I have. Thanks.
Thank you. Thank you to our speakers. I think it would be a good idea if all our speakers came up so that we could start a panel. And are there questions in the room? We'll take questions in the room first.
Okay, thank you. Very nice presentation, all of you. So this question is to Travis. In your equation to calculate the BM2.5, you have several extinction coefficients and radius and few things. So what are the source of those data and how variables are those and how that impacts your estimations?
So are you talking about the mass extinction efficiency?
Efficiency and
Yeah.
the parameters.
Yeah, so the mass extinction efficiency, we're just taking from the literature and we're taking some just vague assumptions about that based on aerosol type. So that's where that's coming from. And then the extinction coefficient we still have based on aerosol type classification as well. The other parameters, so there's aerosol hygroscopic growth, that's also based on a lot of the work that that came out of NRL, like James Campbell, Jeff Reed, and those folks. And then aerosol size distribution is just based on studies that we've done looking at how PM 2.5 and PM 10 relate to one another. So we back out like a rough estimate of that to try to take that into account.
Okay,
Yeah.
thank you.
Yeah.
Sure, thanks so much for the really nice talks. My question is probably more geared towards Leif and Amanda from your roles at the state air agencies. And I think it's pretty neat to see how much and how many different types of satellite data you're bringing into your work. And I guess my question for you is sort of either kind of what barriers you hit or ways that sort of a community like this could help to make the door a little easier to open for others who are interested to follow in your paths, and or what, if you had a wish list, what additional information would you like to have, especially if you know that something's out there but you're finding it challenging to access on the sort of rapid timescale, whatever timescale that is, that you need that information.
Yeah, so I guess I'll go first. I guess the biggest challenge I had was knowing who to reach out to for what question I had, and coming up with a very specific question that someone could answer. If I had something vague, I just want to know how to do this, that wasn't necessarily helpful. It was figuring out what I wanted to ask and who to ask it to, and that's where meetings like this are helpful, because you learn and you make those connections, and that's what's helped me be successful. But going forward, I think it's just continuing to show up, continuing to show what we've done, and continuing to get feedback from people in the audience and people, the scientists who are behind the data.
I'll echo that too. From our perspective, more one-stop shopping, if that's possible and realistic, and sometimes it's not, as there are so vast resources. But I believe, training opportunities, I believe, Paulson, you mentioned it earlier at the start of our meeting on consolidation of all of these training and resource opportunities for air quality, air management staff that don't routinely dabble in satellite remote sensing would be a great bonus. Training of that, and I think I mentioned it at the end of the slides as well, but these events happen, and it's more of a, oh my goodness, the episode or event happened. Trying at that moment or within a day or two of that moment to grab information, to capture the satellite data if it's readily available, is kind of the big key, because it's just so easy when other priorities happen in an air management world that you have to shift attention to.
Hi, I have a question for those of you that work with the aerosol layer height product and the aerosol centroid height, as to what the difference between those two products are, or are they the same product?
Actually, for the tempo data, actually they are the same concept. They have the same definition. Since the part about the assumption of the aerosol vertical distribution is the same in different product or algorithms. Yeah, so I think the different part is about the LD retrieval. We use different method and algorithm to retrieve LD, and this LD retrieval will influence the LSH or ALH retrieval. So that's the difference. But about the vertical distribution assumption and the simulation about this outer layer height or LCH, that's the same.
Okay. Then I have a follow-up question, if that's okay. I think Amanda mentioned that the aerosol height is only retrieved when the AOD is greater than 0.2. But have you thought about when a dust plume or smoke plume is so thick that there is no aerosol optical depth retrieval since it's flagged as clouds?
Yeah, that's possible. Yeah, if there's cloud contamination, yeah, we cannot get any retrieval of the LD and LCH. Yeah, and we have the threshold for the LD since that if the LD is too low, it's hard for us to get like the significant or accurate information about the outer layer height from the picture thermal sensing. So that's like the technical challenge here. Yeah.
Thank you.
But it wasn't real cloud contamination. It's the case when you have thick enough real aerosol, not cloud, that the algorithm fails for tempo or goes or whatnot, simply because you can't see the surface. If you can't see the surface with a passive instrument, you can't get an AOD value, but you can still get height. So have you thought about if there's ways to actually still get the height?
Yeah, that's some good questions. Yeah, we're working on keeping improve our algorithm to capture more observations. Yeah.
Thanks. All right, we have a question from online for Travis. Has the platform been evaluated against 24-hour FEM or FRM measurements using equivalent averaging periods? And if so, what level of agreement was observed?
So yes, but I don't have the specifics in front of me. I don't remember that. So yeah, it has been, we've looked at that from more of an overall perspective, but not in great detail, so.
Okay, thanks.
Fine, Travis, that'll help. Not everybody. FRM.
So that's just one of the methods that the EPA uses, so it's a kind of the federal reference method. So, but I'm drawing a blank on the
Equivalent.
Yeah, so.
I have a question for everyone, kind of exploratory. It's my favorite question to ask scientists. If you were given a blank check, what is something you would invest in that would just solve your problem instantly? Maybe that's a type of satellite, is it coverage, like what would be most beneficial to you?
I have an answer.
Well, I guess I'll go first. So I think the one thing that's helpful is getting data as quick and easy as possible. So for instance, the AOD and ALH is about 2 to 3 hours per time for latency. I guess their goal is less than 2, and the quicker we can get that data, the better. But that's, I understand, not something that you can necessarily always have it within 5 minutes, but it would be great if we could. It would make forecasting more timely, especially when we need to issue alerts to the public.
Well, to see through clouds first, but for us, the more the federal reference method, federal equivalent method monitoring, that mobile station that I showed, oh goodness, the procurement of all those federal equivalent method monitors and the ones that are being built now with some low-cost sensors added to them, easily several thousands upon thousands of dollars, and having more resources for that to go to communities that would be beneficial.
Well, I'll just say, you did mention like if we have an unlimited budget. So of course, I'm gonna say more LiDARs in space, which is not probably realistic, but if we had 2 or 3 that we're observing at different times, like once in the morning, once in the afternoon or something more regularly, that would be incredible, you know, but it's because of the costs and just other things, it's probably unlikely.
And Leif?
Yeah, I just want to add another thing, consideration about like integration of different satellite platforms, like including the LEO and GEO and even some satellite from JAXA and ESA. So we still need some integration to take advantage of each satellite product and try to compensate some shortcoming of different satellite platforms. Yeah, as well as including some ground-based measurement to help us to crack the bias from the satellite data. So that will be, I think that in the near future, that will be our research goal to involve more data and make a kind of like reliable and general data sets that applicable for and easily appliable by the stakeholders. Yeah.
Before we get off this topic, I have one more question for the stakeholders. You both mentioned near real-time data and that being a need. So what about the data like the LiDAR that has a vertical or what we use listening providing? So is this kind of data useful in a retrospective analysis, or is that all you're interested in alerts? Do you see the value of something that takes longer? Is that valuable to you?
Yeah, I think for what I do a wide range of things at the state of Connecticut, and it is important for both the near real-time data for forecasting and alerts, but also for creating the SIPs or exceptional events demonstrations or and analyzing events. It is also important for those other products as well. So it just kind of depends on what we're working on in the moment.
I like the retrospective part of, I don't look at it enough, but the Calypso data, just to see when it, I know that's such a narrow swath it covers, so there's a little bit of random luck and hope involved at times, but seeing when it does cover, say, a community or something to add a weight of evidence approach to an exceptional events demonstration.
Hi, I'm a science journalist, so I'm going to ask a very basic question, but I write a lot about public health and air quality, and I guess I'm just curious, I mean, I've heard for a while that tempo is going to be a game changer, and I want to know how, and if it's already changed the game, or will it change the game, like in both regulatory frameworks as well as research, like what is being changed as a result of tempo?
So the biggest thing with Tempo that I can think of is we have access to hourly data, where like with Tropomi, we can access NO2 data, but maybe once per day. With Tempo, we can see with near real-time data what the tempo levels are, for instance, in New York City, because that's what tends to impact Connecticut. And then you can see how that NO2 plume is transformed or moved, or like how that data kind of like what plays out throughout the course of the day, rather than just getting one little snapshot of that day. So just access to more times and more data.
So just quickly on that, is that helpful for forecasting? Is that helpful for exceptional events? Is that for everything? Or like what's the main thing that helps you do?
Yeah, so it helps for the near real-time tempo data. That helps for a tricky forecast. So for instance, ozone, we're really on the fence about going USG or not going USG, so like issuing alert or not. And if we can see a really significant NO2 plume and we know what the winds, or what we expect the winds to do, that might push us to go more towards issuing the alert rather than not. So that decision making, but also in use for like our SIPs, so our state implementation plans, that data is also helpful in maybe just showing how the plume was transported along the I-95 corridor throughout the day. So that's how it's useful for us.
And, we use Tempo a little for exceptional event demonstrations, as you mentioned. I've also seen, and I see one of our Western State Air, oh gosh, I'm gonna butcher the acronym.
Western States Air Resource Council.
Western States Air Resource Council, apologies to that, but they've provided beneficial Tempo training to Western state and local air regulatory agencies and sit on some webinars and calls for them. And I've seen other states use it for investigating emissions from oil and gas operation activities, other facility activities. So it does have a wide range of promise and benefits beyond maybe a fire or other forecasting as well.
So I'm going to just add to this, and you guys might want to add to it. So if they're issuing alerts, then that goes to people that are at risk. So it could save people's lives, children, elderly particularly. And people that are at risk do listen to these warnings. So that's health, and it's also the economy, since air pollution is very costly. So it's a couple of ways that it actually helps. And seeing during the time of day actually lets you know where it's coming from or where it will come from. So it's headed your way. So you have a chance to have people not go for a run or stay inside and turn on their HEPA filters. And also with the daily information that, well, actually it's not daily. I mean, when we put this all together, it provides enough information that people know how to plan in advance. So how do we get filters or AC or whatever we need to do out to communities and schools or places that people that don't have the financial ability to take care of themselves. So, and that ends up being less costly for us all than emergency department visits. And we have a question over here.
Well, thank you all for the wonderful talk, and I have a question regarding maybe to Travis and she perhaps. And based on my understanding right now, there are two approaches for smoke modeling, especially for vertical aerosol categorization. We have satellite observation like a Tempo Ghost Views, and also we have the physical process-based modeling, such as Travis that just demoed by the Wolf for CMAC, as well as known as her smoke. And what's your thoughts on their advantage and also maybe disadvantage of both approach? And especially based on the demonstration, it seems like a CMAC underestimate the smoke. And so basically, what's your thoughts and vision for in future how we best leverage both approach for improved smoke modeling and forecasting? Thank you.
Yeah, so I think she probably can take this, but I just want to follow up with that. Like what I was showing with the CMAC was not just smoke or dust or anything. That was kind of all in together. So.
Yeah, that's good question. That's actually our like satellite data. That's observations. Yeah, we are trying to improve. Definitely, there might be some like bias or uncertainty in our product, but that's observations. And for the model, they are influenced by a lot of things like input and some like physics and chemistry structure in the model. So definitely, I believe that a comprehensive way is to combine these different approaches together. Like there's some different methods such as the data assimilation to assimilate the satellite data in the model system to provide more reliable to provide the model results agrees better with the observations. And also there's like the machine learning method try to get the input information from model, from ground observation, from satellite observations to make the forecast more accurate and easily. So I think the methods and technicals are improving, and we are looking forward more accurate forecasts to applying as many as data source we have and the approaches we have.
We have a back here. It's online. The next question is online. So if you can pass it.
Yeah. Yeah, just for a question for Leif and Amanda. So I completely understand like there are exceptional events, you need to put out these alerts to the public. But I was wondering if you have ever thought rather than going like a bit, like have, I don't know, like air quality campaigns where people can understand a bit more the implications of PM 2.5 or air pollution on their health. Because yeah, like you have a fire or whatever, of course, there's warning. But making sure people understand like, hey, a rise in 20% in PM 2.5 levels will have this and this and this effects on your health, and take this and these precautions. So I'm just wondering if that's something that you have thought.
We do have basic health information on our webpage. Most of it's linked to EPA and some web pages that they have. But that's kind of all that the state of Connecticut has been doing. I don't know.
Well, we are strictly an air regulatory agency also and have clear boundaries between us and the Department of Health. We do though, like Amanda said, have on our YVisNet air monitoring website just various, the AQI collars and the health effects of that. We've also worked on, we have an ozone non-attainment area for wintertime ozone. Us and the state of Utah are the only states in the country that have this phenomenon. But we have a power of partnership encouraging, working with industry and the general public on understanding how we can all work together to mitigate ozone formation in that instance. But it's kind of our activities with that.
Hi, I have a question for Travis. The LiDAR and PM 2.5 estimation and retrievals are very helpful, not just for the US, but since it has global coverage, it's very helpful for third world countries who doesn't have good coverage for surface monitors. I'm just wondering also with the continuity of the satellite, the LiDAR from satellites, I know that the athlete has the 355 nanometer channel. Does that improve or inform the LiDAR-based PM 2.5 in the future?
So yeah, so that'll depend on what we're looking at. So that'll be better for the smaller particles. So for the smoke, not maybe a little bit more challenging for the dust, but we still have the fine moan component of the dust. So yeah, there'll be things we'll have to take into account when we're converting that. So we'll be using different mass extinction efficiencies and those sorts of things. So it's equivalent to that labeling. And as for your first comment, we have done some work with other countries. So for example, I didn't show any of that here. We have a side project looking at India. So that's something that's unrelated to HAQAST, but just showing what does the distribution look like over India, and because we know that it's a very highly polluted country, and how can LiDAR data help with that? So definitely, thanks.
Hi, thanks so much. I had a question for Leif. So you were looking at the elk fire and you showed PM exceedances but no ozone exceedances. I was wondering if you also had VOC data to look at and whether you saw a spike in that.
Yes, so that mobile station is equipped with a hydrocarbon analyzer, methane and non-methane hydrocarbons. I don't recall, I'd have to maybe dig a little deeper, but I don't recall anything that was quite noticeable in the parts per million carbon scale. With that, but we do have, those mobiles are equipped with that. And I think the new ones we are building will also be equipped, and maybe we'll have additional SUMA canisters and other tools to analyze VOCs.
We have another question online for Leif. When evaluating low-cost PM2.5 sensor performance, does the state of Wyoming DEQ primarily rely on light scattering FEM instruments, BAM instruments, or filter-based gravimetric measurements as the reference standard?
Yes, we use, for federal equivalent method, we use MET1 BAM instruments, continuous PM2.5 monitors, which are BAM beta attenuation is the technology behind that. We do have at 2 stations due to EPA Code of Federal Regulation requirements, filter-based gravimetric monitors as well. And we're just beginning to start to analyze sensor data.
Yeah.
Thanks. This question's for Travis. So obviously the uncertainties in aerosol water sort of all over the challenges you're working with, but when I see comparisons between the LiDAR and the model like that, and they're so different, that's where my brain goes first, and then I'm like, oh, the East Coast or West Coast where it's more humid seem to be worse, but then the Mountain West seems to be better where it's drier, and so have you looked into?
Yeah, that's what we're kind of looking into. Yeah, we haven't really found anything yet. But there's a possibility, yeah, of course, of that sort of thing happening.
Yeah, and just getting the aerosol swelling right in the model where you have subgrid relative humidity gradients is.
And especially that feature off the coast of California there that's really strong that is not showing up as much in CMAP, but yeah.
Thank you. So this is question to Shi. I want to come back on the aerosol layer height. I'm wondering if you can talk a little bit more about how you validate them and what kind of uncertainties we have in current tempo products and how that is going to propagate into your PM2.5 estimation.
Yeah, thank you. So the current validation for the aerosol layer height, right now we use the LiDAR data. We validate the aerosol, we calculate some kind of like aerosol optical depth or aerosol extinction weighted aerosol layer height from the LiDAR vertical distribution. And we quantitatively compare this with the LCH retrieved. We have done this for the troponin data, and the current uncertainty of troponin data is around like 1 kilometer. We are still investigating the how this uncertainty of the LCH influence the surface PM2.5 estimation, and but we are trying to use some kind of like machine learning technique to involve the LCH observation to the PM2.5 estimate. And I think the machine learning technique has some kind of capability to remove some systematic bias automatically, since we let the model to know what is the true value. We provide the ground truth for of the PM2.5 for the model. So that's the machine learning model might help, but we are still investigating that. And for the tempo LCH, we are still working on some case studies, We are, so the operational algorithm is still developing, funded by the NASA. Definitely we will use spaceborne LiDAR to validate. But since the discommission of the Caleb, so for the tempo, we can only use, fortunately we have the Earth here, we have athletes, so we can still validate, use the spaceborne LiDAR. And the ground-based LiDAR also provides some significant data for us to validate, but with a lot of efforts for us is needed to validate with the ground-based LiDAR since the data quality, some kind of different among different sites. So we need to contact the PI of different sites for the validation, but that's still helpful. Yeah. Thank you.
So do we have any more questions, either online or in the room? We're getting very close to 11:30, so we've done a really good job. I would like to, in our last few seconds, if you can each take 30 to 45 seconds, if there's something that you want to say that hasn't been said or discussed, it's like what I'd really like to say is that we haven't discussed. If not, just move on.
I don't think I have anything.
Maybe I will advertise our tiger team, Traverse. Yeah. We will continue work on some dust and smoke demonstration but for our tiger team led by Traverse, we'll focus more on the dust plumes that we might not so much concerning previously, and so we are open to any more stakeholders involved. So if you are interested, feel free to contact Traverse.
But just thankful for including state and local agencies in the HAQAST meetings. It's beneficial for us. Thank you.
Thank you so much for being here, and especially for the stakeholders. And hopefully what we can do is, even in listening to everyone, I would like for the stakeholders here to connect with both she and with Travis, and the examples that you were showing. So just what we can see and improve, and we really appreciate you being here. And stakeholders particularly, don't be afraid to ask us for something. We may or may not have it, but at least we'll know what you're thinking about and the direction to go, how we can all work together. And this has just been a fantastic team, HAQAST.